Hello and welcome to Chisel, JavaScript Inside Out series. In this episode, we shall sift through the fundamental aspects of IIFE, also known as immediately invoked function expression, and closures. Without much ado, let's dig in. First, we shall look at IIFE, a couple of use cases with some examples, and then we move on to closures. So IIFE stands for immediately invoked function expression. It is a pattern in JavaScript which helps us to define and invoke the function, right? You define and invoke the function immediately. So there is absolutely no need of an external trigger. Let's move on to its syntax. It's pretty simple. You could see the color coding. You have an anonymous function. You could see that in highlighted in pink. It's a function and it becomes anonymous because we don't associate a name to the function. And you also see couple of braces or parentheses. You have the first parenthesis, which encloses this function, and you also see the second pair of parentheses, which helps to invoke this function. So this first pair of parentheses helps the function to be treated as an expression, and the second pair of parentheses helps to invoke the function. And it is important to note that if you want to invoke the function immediately, uh, then the function has to be treated as an expression, and the outer pair of parentheses does that. Okay, it helps your JavaScript engine to treat a function and the anonymous function as an expression, and that will help you to invoke that function immediately. Okay, so this pair of braces could be inside the outer pair or outside of this pair. So both are valid, and but this is the preferred approach. And an example code, you have this outer pair of parentheses and an anonymous function here. You pass the parameter inside this function and you have a block of code inside. Okay, this is pretty simple construct per se. So let's look at a very simple example, and I'll open the VS code to run through this code snippet. This is an IIFE, how you define an IIFE, and the return type, right? So this is an IIFE, and I've used this the second pair of parentheses outside of the first pair. So this is also a valid syntax. So what essentially returns is the value, the constant shibu, right? The string shibu is returned into this IIFE variable, not the function per se, because this function is defined and it is invoked as well immediately. Okay, so what this holds is not a reference to the function, as in the case of a regular function, but it holds the result of the function. So if you look at the non-IIFE mode, this is function expression, and you know after you run this piece of code, right? So this holds the reference to the function per se. Okay, so let's run this code and see what it returns. Refresh this. You could see the results. So the IIFE variable holds the value shibu, not a reference to the function. But if you look at the non-IIFE variable, it holds the reference to this function. Okay, that's how it behaves as far as uh, the results are concerned. What actually gets into the variable, right? The function variable is concerned. Let's move on, and some of the use cases, right? So why IIFE, where IIFE is used, couple of key things around the use cases have if there is a need to create a new scope that is hidden from the global scope, you work with IIFE. And if you want to protect the variables and functions from getting overwritten, right, from or manipulated by the external code, so you have, the next example would actually demonstrate the concept around this one. And the second use case where if is used to avoid polluting the global namespace. So look at the second piece of code, which essentially helps to protect the functions defined inside the global scope. Okay, here we go. So this piece of code is pretty straightforward, simple. You have a function which is named validate, and somewhere down the code, down the uh, file, you have another function with identical name. So this takes the user name as an input, and this takes input as a parameter inside this function. Okay, so the thing to be noted is the function name is identical. So what typically happens, we'll we'll take a look real time. So let me refresh this. Okay, go to the watch window, and I have a validate function. Just check which one it points to. Okay, which function it points to, right? Let's see, it is pointing to the input validation code. So it is pointing to the second validate function. So we lost the first validate function because it got overridden, because both these are as part of the global scope, and the last validate function has overridden the previous one. Okay, so how do we work this round? So we need to have this, but still we wanted to retain both these functions with the validate name. How do we work this round? Here comes IIFE. So IIFE becomes handy in these situations. Okay, let me comment this out. Move on. That scenario. Okay, on this code, I get to see, if I run this, I get to see both the console logs. Username, that's one of the console logs, and this as well. Okay, Shibu should be printed and Kali should be printed, right? So this helps us to ascertain that both these validate functions did execute. Okay, run this code now. You can see both getting printed. So both these functions are available within its own scope. Okay, so how did we work this around? Just using the IIFE. You could see there's the parenthesis enclosing the function, and again another pair of parentheses enclosing the other function, both with identical names. Okay, so this is a general idea around IIFE. Let's move on. Now let's take a good look at the concept of closures. Okay, it's pretty interesting, let's say, interesting concept. So closure is a function that has access to the the lexical scope of its outer environment. Or to make simplify this, you say that it has access to the variables in its parent scope. So you have a function, and you also have a nested function, a function inside a function. And the nested function references the variables um, outside of its scope. Okay, so it essentially means, and it can reference, the point is, if it is a closure, it can reference the variables defined outside of its scope even after your outer function has completed or finished its execution. Okay, so this is possible because the function's scope chain remains intact even after the function has finished executing, and the function maintains a reference to the outer variable. So this is important to understand. So to simplify this, you consider two functions, a function within another function, and the inner function referencing some of the variables in the outer function. And you invoke and you return the inner function while invoking the outer function. Okay, you invoke the outer function, return the inner function, and then later on invoke the inner function, and the inner function is referencing the variables defined in the outer scope, but still it works. Okay, because somehow the inner function maintains a reference to the lexical scope of the outer environment. So that's important. So let's it becomes clear if you run through this code, this piece of code. You have a function called print my full name and a variable first name. Okay, and the first name variable is within the scope of print my full name. And you look at the next function which gets returned when you call print my full name function. It returns another function which is again an anonymous one, which takes last name as the parameter. But the interesting part is what gets printed, right? What gets returned, in fact. So it is returning the first name and and gives a space and then the last name, right? So last name is something which passed to into this function, but the first name is picked from the outer scope. Okay, so now you are invoking the print my full name function, and it is returning this function. So the full name variable points to this function now, and print my full name function has finished its execution. Okay, so it's completed its execution, and now we are invoking this particular function. Right now you're invoking the function which got returned using this name. So full name of Kali. So Kali is passed as an into this function as a last name. That's fine, fantastic, because that's within the local scope. So last name, printing the last name is fine. But how did the first name get printed? So you get an output as Shibu Kali, but what happens to the first name? So the first name, this particular function still maintains a reference to the first name variable, which is defined outside of its scope. Okay, so again I repeat, you invoke print my full name function, and this full name function returns the inner function. There's an anonymous function is returned, and it gets pushed into the full name variable, and this the outer function completes its execution. Okay, it's completely done, and now you are invoking the full name function, passing Kali as a parameter, which gets pushed into the last name. But still, when you print first name and last name, the inner function still maintains a reference, right? It's able to print Shibu. Okay, so that's the concept. So from the concept perspective, your inner function, even your outer function finishes its execution, but your inner function still maintains a reference to its outer scope. Okay, to its lexical scope of the outer environment. So that's the concept. Let's run through this real quick. Okay, refresh this. You could say Shibukali getting printed. So that's the basic idea, the concept around closures. So let's look at the formal definition first, and then move on to an interesting scenario using closures. So in a nutshell, the nested function remembers and has access to its lexical scope even when the function is executing outside of its lexical scope. So that's what the formal definition of closures mean. Okay, so let's move on to another scenario. So for this case, I have a simple HTML document with three anchor tags. Could see this, three anchor tags: upquotient.com, OO, O1, and O2 upquotient.com, just to display it one after the other inside an HTML page. Then comes the JavaScript. It's again a reference from the website. I've picked it from this website. It was a pretty interesting read. If you want, you can read through the other situation scenarios on closures and IIFE and closures both. So here what we are trying to do inside the JavaScript, I am getting a handle to all the anchor tags. Okay, I'm pushing this get elements by tag name is going to return node list. So the elements is essentially a list. and each item pertains to the tags here, pertains to the elements here. Okay, so three different elements. And I have a simple traditional for loop iterating over each of these elements. And I have an event listener. So I am associating a click event listener to each of these anchor tags. So when you click each of these anchor tags, all it does is to invoke this function and display an alert message. And the alert message should essentially, you know, display the order of the links, right? So it should display 1, 2, and 3, etc. That's the intent. Okay, so will this work is what we are going to check. Okay, so let me comment this out, comment this, and okay, and uncomment this part. Cool. Save this, and I will also show you the HTML file. Okay, so this is linked, the JavaScript file is linked, and I'm going to pick each one of these elements from this document using this line of code, right? This line of code, and iterating over each of these anchor elements, and associating a click event listener. All it does is you click the link, it pops up an alert message and shows the order of the link. Is it 1, 2, or 3, etc.? That's what we wanted. Okay, so will it work in that way is what we will see now. Okay, and here is the code. I click on the link, it just says 3, each of these links. Okay, so it doesn't work as expected. Okay, why is that? Because what happens is, right, so you are trying to associate the the event handler with each of these elements. By the time your running variable has already been executed 3 times, so the i's value is 3. Okay, it doesn't really hold the state of the I variable when this function is getting associated. Okay, so formally, let's say this doesn't work like you might think, because the value of I never gets logged in. Okay, that value of I never gets logged in. Instead, every link when clicked, okay, alerts the total number of elements, because that's what the value of I actually at that point in time. So idea is we need to find a way when you associate this function, right, this event handler function with the elements, you need to lock in the value of I at that point in time. Okay, so that is not happening. So how do we work this around? So workaround is using your IIFE. Okay, let's take a good look at this code. It's pretty simple, the same traditional for loop here, and I have a function. Okay, I have a function, and I pass on the the parameter logged in index, and I'm passing I into this local variable, and this is a fee, right? So the whole thing is the IIFE. Okay, and everything I have is identical, so there is absolutely no change. So what happens here is you have this running variable I, you pass the running variable into this particular local variable, which is local to this particular function, and this gets logged in. Okay, so when this function is getting linked as an event handler to these elements, let's say first element, the value of I gets logged in. Okay, so the value of I gets logged in. So um, when you link this particular event handler function to the first element, the value of I is going to be 1, because here you pass 0, and I'm adding 1 to whatever is passed. Okay, so 0 is passed and 1 gets logged. Okay, you're incrementing it with 1 gets logged. And for the second element, okay, for the second element you're passing 1, and here it 2 gets logged. So the time when the function is getting associated to each of these elements, the value of logged in index gets logged. Okay, the state is maintained. So that's the speciality of IIFE. Okay, that's the speciality of IIFE. So let's run this code and check how it behaves. I'll comment this out, move here, and comment, uncomment this. Cool. And these are other variations that I will sift through. Okay, refresh, click here. You see one, and this should print two. The other one should print three. So essentially, the state is maintained, and different ways to write the same piece of code using an arrow function, using the arrow function directly without linking it with a name. There's another way you have an IIFE on the event handler alone, and this is surprisingly yet another way to do it. So you are assigning it to a on-click event, and this essentially is an expression. Okay, so you don't need an extra braces to to pass on the message to your JavaScript engine that this has to be treated as an IIFE. So, but because this notation itself, right? This notation itself is an expression. So the function expression. So this extra pair of parentheses can be avoided. Okay. So this is what I have to discuss, and we are done with this. We'll catch up with at another concept in the next um, episode. Thanks for watching. Take care. Bye bye.